Hi, everyone. My name is Ryan Smith. I am an EDS student in the Instructional Technology program at Kennesaw State University. I took a break of a few years from the program to care for my son who was diagnosed with autism while I was in the program for the first time. So I'm coming back after 3 years to complete the program. And this project is my capstone project. It was started the first time that I was in the program. So it's going to be probably a little bit of a unique presentation because fortunately this program did catch on and I was able to grow it over the last few years. I'm mostly going to describe what it was like during the first year, but I'll include some updates with that presentation as well. I am currently a teacher at the Green School in West Palm Beach, Florida. This is my 10th year teaching. In addition to that, and this is where this program is run, I have worked with the South Florida Science Center and Aquarium as a camp counselor, a camp manager, and over the last 5 years as a program coordinator for this program that I developed 5 years ago. So the program is called the STEM Inventors Challenge, a multi-school 3D printing competition, and I'm going to describe the genesis of that project and where it's currently at right now. So this project began with some conversations between myself and one of the educators at the South Florida Science Center and Aquarium. I had recently read an article in U.S. News and World Report that said that by 8th grade, almost 50% of students have lost interest or deemed science irrelevant to their education or future plans. So that was alarming to me and to him because of our experiences within the STEM fields. And the engagement that we had seen with students. That's also a problem because STEM jobs pay more. They are growing faster than non-STEM jobs. And so it's important that we prepare students for jobs of the future. And one of the other problems that we had identified was that students aren't typically exposed to emerging technologies in middle school. Most of them have not seen, or at least at the time, it's getting better now, but at the time, most students had not seen or used a 3D printer, a laser cutter, microcontrollers, any of the STEM equipment that is currently being integrated into classrooms right now with much more frequency. So the opportunity that we identified was that when, in our experience, the highest levels of engagement that we had seen were when students were introduced with problems that were related to the real world, that required a unique solution. There wasn't a one-size-fits-all answer to it. And we also saw high levels of engagement when we integrated those emerging technologies. So it's a good hook, if nothing else, to get those students in. But in addition to it being a good hook, 3D printing offers unique solutions that you would not be able to develop without having that technology. It was also a great opportunity. The timing was perfect because the school district that I was part of at the time that this began, when I was with Polo Park Middle School, the school district of Palm Beach County, was really starting to push STEM initiatives. So they had started a STEM curriculum team at the district, and they were starting to integrate it and put a focus on integrating it more in the classroom. We also identified this as an area of opportunity because we knew it was going to be expensive. And over the years preceding this, I had written several grants, one of which was a $36,000 grant for a makerspace at my old school. So we felt comfortable putting a plan together. And so our solution was to develop that plan, submit it to the CEO of the Science Center, Kate Arisa. She's a CEO now. She was a COO at the time. And we wanted to develop a middle school 3D printing competition that would pit schools against each other, and also include makerspace workshops that would introduce students to some of the other emerging technologies and skills that we had used, such as those microcontrollers, drones, rolling and flying drones, and block-based coding too. We actually did some of that in our makerspaces. So the initial plan for the program was to invite 20 schools to participate in the challenge. We wanted to give each one of those schools a 3D printer in addition to 2 rolls of filaments. And we were going to ask those schools to form teams of 2 to 4 students. And those students would complete 3 mini challenges. And those mini challenges were designed specifically to develop either 3D printing skills or to develop design skills, right? And so the 3 mini challenges that first year that we began the program were the toddler toy challenge. And the skill being assessed there was to create holes and to learn how to group objects together, including a solid object with a hole. The second mini challenge was a classroom connection challenge. And the skill that we were assessing was incorporating measurements of real world objects into digital design. So, for example, if I wanted a clip that was going to fit onto the edge of the table, I would need to know the size of that table. And that also teaches students to learn something called tolerance. The 3D printers don't print in the exact measurements that you have online. They're pretty close, but there is some wiggle, and you need to learn that about your 3D printer as you're printing. And the last mini challenge was a penny boat challenge. And the skill being assessed there was to design something while being given clear constraints. So the penny boats had a size constraint, and we also gave them objects like a hole or a base that they needed to build their boat on top of. And so those were the 3 mini challenges. The final challenge was that we were going to ask teams to develop an invention that used a repurposed item and solved a unique real world problem. So again, we wanted students integrating real world objects in their digital design process. And then we also asked students to create a 3 to 5 minute video describing their journey, the design thinking process, how their invention evolved, what iterations it went through, and if they had multiple prototypes, what those looked like and how they modified and improved them. We initially wanted to invite 20 schools to participate in the program that would then come to our makerspaces, and we were going to introduce students to those emerging technologies, microcontrollers, rolling and flying drones, Littlebits, which is a rapid prototyping tool. We also were going to go into a little bit more depth in the engineering design process. So we had students do things like complete an engineering challenge, like a simple index card tower, seeing who could get it the highest with a set amount of index cards. We had them design obstacle courses, and we also had them, we wanted to have them use block-based coding to program the drones to navigate an obstacle course autonomously. And then the last part of the overall challenge was to have the schools attend a finale where they would display their projects. And we also, and this was implemented, in the initial plan, we did not have them doing boards, but we quickly realized that in order to have a live final challenge, we were going to need to have them do something physical. And so the kids did science fair type boards that were displayed along with their inventions. And we wanted to give them some pretty significant prizes for those challenges. And I'll go over those a little bit later. This first plan was targeted mostly towards Title I schools. That was what I wanted, to target Title I schools that were serving lower income students, and also organizations that worked with those types of schools or student populations. So we put the initial plan together. It was approved by the CEO. I ended up writing a grant for the America Honda Foundation for $75,000. Unfortunately, or fortunately, really, because our alternative route allowed us to continue the program year after year, the American Honda Foundation denied the grant, and we resubmitted it to the Stiles Nicholson founder, whose founder is David Nicholson, who's a major contributor to STEM education in Palm Beach County. So he donates a lot of money and is very influential in the county. He approved the plan. The budget came down a little bit, but he also wanted us to reduce the number of teams from 20 to 5, and he did not want us in that first year to focus on Title I schools. I initially didn't agree with that, but looking back on it, it was probably the smartest thing that we could have done, because we were able to work out the kinks with schools who came in with more support for their students, and we were able to figure out what we were doing right and what we were doing wrong, and then move in more of those Title I schools and organizations later on, once the program was more established. Our approved budget was $55,000, and annually we get between $40,000 and $65,000 for this program. In order to evaluate the success of the program, and I'll go over these metrics later, we did a pre- and post-competition survey of the participants, and we also had the projects evaluated in the judging process by engineers and technologists. And we also, at the end, did a focus group of the winning schools to figure out what went well with it and what they thought we should improve. The 4 components of the challenge that we went over were first, we did go over the mini challenges, the makerspace workshops, and the final challenge, but we also had a training component too that I'll describe in a second that over the years has also improved. So in that first year of the program, only the teachers were trained on Tinkercad and the hardware. So we only had a group of 5. I think one school had 2 teachers, so we had a total of 6 teachers come in that first year. We went through Tinkercad with them. I gave them some documentation on or some packets on the engineering design process, and they were then asked to bring that to their students and teach them. That worked okay for that first group, but it was not going to work year after year. And it worked actually okay for the second year, but beginning year 3, we started bringing students in and did what we call a student ambassador day, where a small group of students would come in, learn the software and the hardware, and then they would be able to help their peers when they went back to school. I also created a resource site, the STEM Inventors Challenge. So the STEM Inventor Challenge website has videos from previous winners. It's got these resources. It has websites pulled from YouTube. And I was really fortunate to have done the Weebly portfolio with Kennesaw, because that definitely helped me build out that website and another site that I'll mention in a second. The mini challenges, here are some example projects for those mini challenges from that first year. This down on the bottom over here, you can see an octopus. That was the toddler challenge winner. We've modified these and changed them a little bit over the years, but in general, they've kind of been related to those 3 challenges. The Makerspace workshops for the first year, we had the 5 schools, and we introduced and strengthened their understanding of the engineering design process, introduced them to some of those emerging technologies that we talked about. It was a really successful experience. Unfortunately, as the program continued to grow, and I'll talk about those numbers in growth in a little bit, as it continued to grow, we had to scale the makerspaces back so that we could focus more on student training at the beginning, since the teachers and students' time was limited. But these were really fun, and I do think that they were beneficial. Final challenge, that first year, all of the projects included a repurposed part. The feedback that we got from the teachers was that the students felt like that constrained their design process and that they could have come up with better projects. So we backed that off after the first year, and they are more open-ended projects since then. You can see down here at the bottom, there is our design, our grand prize winner for that first year. It was a fantastic project. They designed a system to capture shower water or wastewater and convert that into electricity using turbines. So the engineers and the technologists that were judging really loved that project. The last year, because we were forced to go virtual for our finale, I actually ended up having to create a virtual finale website, and we live streamed it over Facebook. It was really a cool experience, and we got really positive feedback. And again, there is 0 chance I would have been able to do that website so quickly without the Kennesaw program, getting me the experience working on Weebly. So I was very grateful for that. Oh, and also one last thing, you can see the prizes over there. So each one of the winning groups got 3D printers. Each one of the students in the winning group got a 3D printer, and so did their teacher to add to their classroom. So evaluating success, the pre and post competition surveys. So this was the initial survey that we asked. It was 3 questions. What are the steps in the engineering design process? How interested are you in a STEM career? And how important is STEM in your life? So for that first question, only 31% were able to correctly identify the steps in the design process during the pre-interview, and 61% was able to answer it afterwards. So we were happy with that increase. We saw a similar increase in interest in STEM careers. Now, I will say that most of these classes were STEM related. They had great teachers. And so I think these students probably had a higher interest coming in than probably most student populations would. But we did see definitely the increase in interest in the STEM career from before and after. And the same thing was true of the importance of STEM in their life. So you can see that about 50% of these kids thought that STEM was important, even going into the competition. We increased that a little bit, but we, more importantly, I think, decreased the 1s and the 2s and the students who thought that it was not important in their life. So that we were happy to see. These are a couple of examples of the winning projects. Some were really complicated, like that first one that I showed with the hydroelectric power. And some were super simple, like this one you can see on the bottom. It simply stops a chair from tilting back, right? They went through a really nice design process. They described it really well, and it's quite frankly an effective product. They demonstrated it. I've used it. Teachers at their school have used it. So really happy with that result. And then the last thing we did was a focus group. So I'm not going to get into too many details. I did highlight some of the things there that we took from the focus group. These were students who were from the winning schools. We brought them in, asked them some questions, did some fun activities with them. This was a lunch and learn, and they gave us fantastic feedback that we have used year over year to be able to improve the program. So the evolution of the competition, can't see it there, but I've already said it. We started off with 5 middle schools. The year after that, we increased to 10 middle schools. In 2019, we increased it to 15 middle schools. 2020 was the year of COVID, so we had increased the program pretty significantly to 18 middle schools, and we started a new elementary school division, but we did have to go virtual with our finale, as I described earlier. We scaled back the number of teams that we had this year because not all of the teams were able to complete the challenge. So we took the teams that were able to. I think we added one new team, but that was a teacher who had done the challenge at a previous school and actually had winning challenges. Actually, both of those challenges that I showed before, those winners, were from her previous school. All right, the major accomplishments of this program: we have handed out 69 printers to local middle and elementary school, and we've awarded 28 printers to individual student winners and teachers. We've had over 400 unique student inventions, and over 1,500 students use the engineering design process. And that's in addition to the over 2,000 mini challenge projects that we have had students complete. We have, in terms of teacher development, which is what that says behind my video, 33 teachers, different teachers, have been given 3D printers and have been trained on 3D printing in the classroom and project-based learning. So what are we going to do next? Our goal is to get up to 50 schools in the next 3 years. We want to have better training. So we are going to think about initially partnering with Print Lab, which has 3D printing software, 3D printing training modules for students. But eventually we'd like to build our own course and do that internally. We also would like to go international, national and international. We want schools from other states and countries. And part of the benefit of having to do the live stream for the finale was that we realized we don't have to have students here. And so that is something that we're considering moving forward. So I'll leave you with this quote: what we learn to do, we learn by doing. That is definitely something that we see with these students. They get on there and they first experience the 3D printing software. They have no idea what to do, but over time they develop their skills and they end up getting really good at it. So that is the end of my presentation. I would like to give a big thanks to SlidesGo. That's where this slides template came from. And you can see a couple of the works that were cited throughout this presentation. So I appreciate you spending the time to view my capstone project, and I hope you enjoyed it. Thank you.